An example of covalent compound or covalent substance is iodine. Now within the iodine molecule, so this is actually iodine molecules. Okay, iodine molecules, the chemical formula is I2. So within the I2, there are two iodine atoms. And these iodine atoms are held by strong covalent bond. Between the molecules, so between the iodine molecule, this is one iodine molecule, this is another iodine molecule. And between these two iodine molecules, the molecules are held by weak van der Waals forces. So the dotted line here is the van der Waals forces, or the intermolecular forces. Okay, another name for van der Waals forces is the intermolecular forces, and this intermolecular forces is very weak. And because of the fact that it is very weak, gentle heating will break down the forces, and when the forces have been broken down, solid iodine sublimes to form purple iodine gas. Because at room temperature and pressure, iodine exists in solid state, and when it is heated, just a little bit of heating, the solid iodine would sublime to become iodine gas. Why? Because the intermolecular forces between iodine molecules are very weak. So this is true for all the covalent substances. All covalent substances, they have very low melting point, very low boiling point. Why? It is because of the weak intermolecular forces or weak van der Waals forces between the molecules. Another example is methane. So carbon and hydrogen, so within the methane molecule, the carbon and hydrogen are held by very strong covalent bond. But in between the methane molecules, they are held by very weak van der Waals forces or intermolecular forces. And because of that, methane has very low melting point and boiling point. And because of that, it has very low melting point and boiling point. Methane exists as gas at room temperature and pressure. So this is in general the characteristics of covalent substance: low boiling point and melting point. And more importantly, you need to know what is the reason behind the low melting and the low boiling point is because of the weak intermolecular forces or weak van der Waals forces. Okay, little heat is needed to overcome the forces. Most covalent compounds are liquid or gas at room temperature and pressure. And also covalent compounds, they are insoluble in water, so the solubility is very important. When it is insoluble in water and soluble in organic solvent, and they don't conduct electricity. In order for the substance to conduct electricity, it must either have mobile ions or mobile electrons. And for covalent substance, it does not have neither one of this. Okay, and the exceptions for this is carbon in the form of graphite, because carbon in the form of graphite can conduct electricity. And also when HCl, hydrogen chloride, sulfur dioxide, ammonia dissolve in water, they form solutions that conduct electricity. Okay, so when HCl dissolve in water, when hydrogen chloride dissolve in water, it will form hydrochloric acid, which can conduct electricity. When sulfur dioxide dissolve in water, they will form sulfuric acid. Actually, they will form sulfurous acid first, and then after that become sulfuric acid, and sulfuric acid can conduct electricity. And likewise for this ammonia, when ammonia gas dissolve in water, it forms aqueous ammonia, which can conduct electricity as well. So these are the exceptions. Okay, so when we talk about covalent substance, you need to be able to draw the dot and cross diagram for the covalent substance. So this is the dot and cross diagram. And another form of dot and cross diagram is like this. So sometimes in the test, you are given diagram like this. You should be able to know that it is actually another form of dot and cross diagram. You can see the O and the O in between, there are 4 electrons. So 4 electrons means 2 pairs of electrons. So in the structural formula, it would be like this. So this one and this one are the same. Okay. Likewise for this dot and cross diagram for carbon dioxide, you can draw it in such a way. Also, you can draw the conventional dot and cross diagram, the circle one. Now this table shows the comparison between ionic substance and covalent substance. So basically for structure, ionic substance structurally, positive ions and the negative ions are held by strong electrostatic attraction forces in a crystal lattice structure. So structurally, it is called a crystal lattice structure. And what are the things inside the crystal lattice structure? Would be the positive ion and the negative ions being held by strong electrostatic forces of attraction. And for covalent substance, covalent bonds between the atoms, there will be covalent bonds, which is very strong. But between the molecules, there will be weak intermolecular forces, which is very, very weak. And then for the melting and boiling point, for ionic substance high, covalent low, and then the reason, you must go back to the structure. Solubility in water, yes, no, no, yes. Solubility in organic solvent, and as well as electrical conductivity. So whenever question asks you to compare ionic substance and covalent substance, some of these things must be applicable. Okay, so this table is very important because it shows you the comparisons for each property for ionic and covalent substance. Okay, this is a typical question. Why doesn't ionic substance conduct electricity at solid state? So you have to ask yourself, at solid state, what happened to ionic substance? At solid state, ions are held in fixed position by strong electrostatic attraction forces, and they are not free to move about to carry charges. So typical question. Okay, the next part is about mole. Now, first thing is, for mole, you need to know the definition for relative atomic mass, or the AR. Okay, the definition for relative atomic mass. Then if let's say the AR of an element is 27, what does it mean? And also be able to calculate the AR for example, chlorine. Why is the AR for chlorine not a whole number? So you need to be able to calculate that, because chlorine exists in two isotopes, which is chlorine 35 and chlorine 37, and after that the calculation you must be able to do. Okay, as well as relative molecular mass. What is the definition? Basically MR and then AR, the definitions are very similar, basically just changing one or two words in the definition. Okay, and then of course when it comes to finding the AR, that is the top number in the periodic table, not the bottom number, because the top number is the mass number. And for mole calculation, remember the triangle, as well as 1 mole of any substance has 6 times 10 to the power 23 particles. This is an Avogadro number. And 1 mole of any gas occupies 24 dm cube. Remember, this one is for gas only. It's not for liquid. I know liquids can have volume, but this volume, this 24 dm cube, is strictly for gas. You get that? Strictly for gas, not for liquid, okay? Okay, then after that is the molar mass. What is the molar mass? Molar mass, this term here, molar mass, basically means mass of 1 mole of the substance. And mass of 1 mole of the substance is basically the AR or the MR in gram or gram per mole. For example, what is the molar mass of aluminium? So, what is the AR of aluminium? AR for aluminium is 27. So, the molar mass for aluminium is 27 gram, which means that 1 mole of aluminium, the mass is 27 gram. Likewise for gas, molar mass of gas, of oxygen gas, that would be the MR for oxygen, which is 16 times 2, which is 32 gram. See, molar mass has the unit. So molar mass by definition is mass of 1 mole of substance, which is the same with the AR or the MR in gram or gram per mole. Okay, this is the examples here. Molar mass is just a term. Then we go to concentration. So concentration, 2 units, gram per dm cube, mole per dm cube, and these 2 units can be interchanged. For example, if you're given gram per dm cube, how do you find mole per dm cube? Basically just gram per dm cube divided by the AR or the MR. Mole, how do you change it to gram? Mole per dm cube, how do you change it to gram per dm cube? Okay, mole per dm cube, how do you change it to gram per dm cube? So basically is multiply by the MR. Okay, and one thing to take note, very important, is that limiting reactant determines the amount of product formed. So whenever the question asks you about the amount of product, you have to always look at the limiting reactant. Okay, the next chapter will be acids and bases. So acids and bases, first thing, what is the definition for acid? A substance which produces hydrogen ion when dissolved in water. First one. What do you mean by weak acid? Weak acid means ionize or dissociate partially or ionize less easily to form hydrogen ions in water. That would be weak acid. Strong acid dissociate fully. That means all the acid molecules will become ions. This one, some of the acid molecules will remain as molecule. Some of them will dissociate to form hydrogen ions. So that actually differentiates between weak acid and strong acid. The properties of acid. So these are all the properties. Reaction. So reaction of acid. First one is acid and metal. You get salt and hydrogen. And which are the metals which do not react with acid? This is actually related to your metals chapter, the reactivity series. Okay, and from the reactivity series, you should know that copper and silver do not react with acid. Basically, the last metal in the reactivity series that react with acid would be iron. And then how do you test for hydrogen gas? The second reaction that involves acid would be reaction between acid and carbonate. You get salt water and carbon dioxide. How do you test for carbon dioxide? And then after that, you have acid plus metal oxide or metal hydroxide. Same thing, you get salt and water. So all these are the reactions that involve acid. Now, how about alkali? So alkali, you need to know, basically you start off with base first. What is base? Base basically is any metal oxide or metal hydroxide. Those are called base. An example. All these are examples. And reactions that involve base, acid base, you get salt and water. Now the group 1 and the group 2 base when soluble in water. When a base is soluble in water, when a base dissolves in water, it is known as alkali. Okay, basically it's group 1 and group 2. In fact, group 2 only stop at calcium, magnesium and beryllium. These two, they are not, for example, magnesium hydroxide, they are not alkali. Beryllium hydroxide also, they are not alkali. Okay, all these bases, calcium oxide, calcium hydroxide, all these are alkali, but not magnesium and beryllium. So actually only part of group 2. Not all group 2 base dissolve in water. Okay, uses of alkali. So alkali, what are they being used for? Okay, calcium oxide, another name is quicklime. Calcium hydroxide, which is your lime water, another name for calcium hydroxide is slake lime, S-L-A-K-E-D. And then the properties of alkali. And of course, the definition of alkali would be when it's a substance when dissolved in water produces hydroxide ion. And then the reactions of alkali, acid-alkali, neutralization reaction. And always remember this is the Ionic equation for all neutralization reaction. That means whenever acid reacts with alkali, this is the Ionic equation that you will obtain. So you don't have to go through all the steps. And then alkali and ammonium salt, you get ammonia, salt and water. And this is the Ionic equation. And the last part, it's about oxides. So there are 4 types of oxide: acidic oxide, basic oxide, amphoteric oxide, and neutral oxides. You have to remember them. Now basically, acidic oxide is non-metal oxides. Non-metal combined with oxygen, they will give you acidic oxide. The properties of acidic oxide react with alkalis or bases to form salt and water. Basic oxide basically is all the metal oxide. And the properties reacts with acids to form salt and water. And amphoteric oxide basically has both the properties of basic oxide and acidic oxide. Okay, react with acid and base to form salt and water. And these 3 examples you have to remember. Okay, these 3 are the examples of amphoteric oxide: aluminum oxide, zinc oxide, lead-2 oxide. And of course, for neutral oxide, you need to know neutral oxide basically do not react with either acid or base. Carbon monoxide, this is nitric oxide or nitrogen monoxide, and this is water. So basically these 3 examples and these 3 examples you have to remember for amphoteric oxide and neutral oxide. Basic oxide, you don't have to remember the examples because there are way too many of them. So basic oxide, you just have to remember that it is metal and oxygen combined. Acidic oxide, non-metal and oxygen combined. And also the indicators. So you need to know the colors of methyl orange as well as phenolphthalein in acidic and alkaline solution. Red, yellow, colorless, pink. The next part is salt. So the solubility table, very important. Which are the salts that are soluble, which are the salts that are not soluble, must remember. Preparation of salts, 3 methods for preparing salt. Okay, so basically in order to prepare, if you are given a salt, and in order to find out how to prepare the salt, first thing is you have to ask yourself whether the salt is soluble or insoluble. If it is soluble, use method 1 and 2. Method 1 or 2. If it is soluble, use method 1 or 2. If it is insoluble, use method 3. And method 2, titration, basically is for preparing spa salt. What is the meaning of spa salt? Sodium, potassium, and ammonium. So for an example would be sodium sulfate. You have to use titration method to prepare it. Potassium chloride, for example, you have to use titration method. Ammonium nitrate, for example, you have to use titration. So titration method is only for spa salt. For method 1 would be for all other salt, all other soluble salt which are not spa salt. Okay, so you have to use the first method. The last part is the QA. Nothing I can help you, basically. You just have to remember. So basically QA, there are 2 parts to identify the anions, which is this table, and the cation, which is this table. And besides that, you need to know how to identify the gases and how to test for the presence of water.